Europe, in Madrid, from where I'm at. And so this subject is about domain-driven design and architectural patterns, architectural approaches. And it is not really about Microsoft or Microsoft technologies. As you will see, you can apply domain-driven design architectural approaches in any platform. Could be Java, could be .NET, could be any other language, but usually any object-oriented language is preferred. But probably the most important platforms are .NET and Java, mostly because DDD is great for complex and large projects. So and then .NET and Java are probably the main platforms, development platforms in the enterprise. Okay. So before getting into the content, I also wanted to tell you a little bit about me. So I've been working in the industry, the development industry, like for 17 years or so, and I also wrote a book about this subject, about domain-driven design and architectural patterns, and I wrote it like 3 years ago or so. So I brought 5 books up. So the first 5 good questions that I get, I will give it to you. Then I also wrote an ebook recently, like 1 year ago, about .NET Technology Guide for Business Applications. You can search for it and download it. That is not really about domain-driven design. It's more about all the different technologies you have around .NET and the Microsoft technologies. And what I did in the last few months is I didn't write this book. This is from Dino Esposito and Andrea Safrello. And this book is also a lot about domain-driven design, and it's been published by Microsoft Press like 1 week and a half ago. So it's pretty new, and but I've been collaborating a lot with those guys, like as peer reviewer, reviewing all the content, giving a lot of feedback. In many ways, it's pretty similar to my book, but all the technologies are up to date, right? So before getting into domain-driven design and what it means, you gotta think about, depending on what kind of application you want to build, you could use DDD or different approaches. Like when you are going to create an application, maybe you think about, hey, for this small app, what I need is most of all productivity and faster time to market. Or maybe you're talking about a large application, like for your core business in your company, and then you are more worried about the quality of service and long-term maintenance and things like that. So that's why we need to use different components depending on what you want to build. Like in that case, what would you build with these components? Anyone? Pretty easy? A car, right? But it turns out that we as developers and software architects, in many cases we build bicycles with car components. So of course we build cars, but I mean, you know that we do it, right? So we have our best architecture. This is super cool. This is great performance, super complex, and sometimes we try to build even a tiny thing with that complex architecture. So that's not the point. And in the case of DDD, you shouldn't use DDD for everything. That's what I want to highlight before getting into DDD, right? So depending on what you need, like if your app is more data-driven, simple application, or if it is a complex line of business application, then you will need different technologies, or most of all, different approaches, right? Like, I'm gonna go fast here, but I created like a application segmentation depending on what you need. Like in this case, we have a data-driven application, simple, and in this case, it is like a complex line of business, long-term application. So you see in that case, maybe you don't really have a lot of business rules. Everything is more like reading data, saving data into a database. It is CRUD it's create, read, update, and delete. And in this case, it's more for your core business. You have a lot of business logic, ever-changing business rules. It's going to have a very long life, but evolving constantly. Integration with different applications, maybe integrating with ERP, with SAP, with different applications, and very task-oriented rather than reading and saving data. It's more about the business processes or tasks, right? And then the priorities are going to be pretty different as well. Maybe for a small application, you want to have it as soon as possible. You need to be fast, and then maybe, I mean, productivity is probably the most important point you're looking for. But if you're talking about your core business, you don't really care so much about being super fast at the beginning of the project. You care more about the long-term maintenance. You want to have like a stable growth of your application. Like if you build that application in 1 year, but then after that, you get a lot of changes. You want to have like the less impact you can have for those changes in the future, right? And most of all, you want to say no, like no to the big ball of math that I will talk about that later. So examples are pretty easy, like departmental applications, collaboration sites, small dashboards. That's kind of the data-driven applications. And if you're talking about core business, insurance, banking, or industry, etc., that's more about this domain, right? And then how you can create those apps. So if they are simple, I mean, in many cases you can use a RAD, like rapid application development, things like in Microsoft Lightswitch or any other simple development. And in this case, it's more about decoupled architectures, domain-driven design, and this is what we are going to talk about. The how for complex applications. Okay. So regarding short-term applications, I'm going to go faster here, but most of all, it is data-driven applications, and I want to highlight that for a large percentage of business applications, it is the right approach. I mean, if you want to build a bike, you need to use simple components. So this is the case for many business applications. But sometimes, and this is the risk, sometimes you start creating something simple and then it starts growing and growing and growing, and this is what we call the big ball of math, because at a certain point you cannot manage that growth in the application, and maybe is this case. It is a data-driven application. Everything is like create, read, update, and delete. But then you really have business logic, but the application is not driving that business logic. It's the user himself who has all the rules in his head. So that's a bad case, right? Because you are having like a lot of business logic that you need to know because of the user's knowledge and maybe a manual or whatever, and then the application is not really helping to drive that business logic. So, and then again, if this application is growing and growing, you will have like a mess in the future. So, if we move to this domain, this area about complexity and core domain business applications, we could say, okay, I want to design and architect my core business and complex application, and what do I do? What kind of architecture and technologies can I use? Right? I can go and reinvent the wheel, think about my own approach, or you can think about architectural patterns and approaches that the industry already has, and that's DDD, domain-driven design. And you can read about it, you can study and apply those patterns. In many cases, you can use it. In many other, maybe it doesn't fit, but at least it's something that it's been proved, right? And even when we are dealing with complex applications, DDD what it's trying to do is to simplify that complexity. It's like tackling complexity in the business, right? So when you have something complex, because your domain is complex, I mean, it's not because we want to have something complex, it's because the domain, the real domain you want to solve is complex, maybe about a health system or industry or whatever. If it is complex, it's going to be that way. So DDD tries to simplify that complexity in different like subsets or pieces, and that's what I'm going to talk about. Okay, and again, highlighting that this is not the right approach for simple data-driven applications, right? So, what approaches you have for like long-term or complex core business applications? You can read a lot about patterns like coming from Martin Fowler, and you can apply those patterns in Java or .NET or whatever, or domain-driven design. The original promoter is Eric Evans. CQRS, which is another kind of approach which is related to DDD, and I will talk a little bit about CQRS at the end of the session, and event sourcing, and decoupled architectures, using dependency injection, so the different components you're using are not coupled, so in the future you could even exchange the infrastructure technologies, or you can it can help you a lot to do unit testing, for instance, if it is decoupled. Solid principles. So there are many patterns and approaches that you can use. And from my point of view, the most important is domain-driven design, which is not a single architecture, is not a single approach. It's more like a way to face your project. And also architectural approaches, and even designing your code, your classes, and the way you create the code. So, like I said at the beginning, it is an approach to create complex software, and this is the important point. In DDD, you focus on the core domain. You have like a domain, would be about whatever, like a transport, freight system, or anything, and when you have like your core domain, that's where you want to focus in DDD. Maybe there are other collateral areas, more maintenance, data, whatever. Maybe you don't need DDD for that. Okay. And then we explore the models, the entity models, collaborating a lot with the domain experts. The domain expert is not someone technical, is someone who knows a lot about the domain, about the real domain. And then something we call ubiquitous language is we need to kind of embrace the language of that domain, like if it is about health or industry or whatever, and take that language and put it into the code. Methods, classes, whatever. Because if we have like something like a translator in between, then we will have a lot of trouble. So that's why it is called ubiquitous language. Okay. And then there's the concept of bounding context, which I will talk about that in a while, but that's a very important topic. When I say bounding context, you can think about like subsystem, like a piece of the large application. Okay. Okay. And also before getting into this, I want to highlight that this is not a silver bullet architecture for all. So you can apply this for your core domain. And something I want to highlight as well is when I'm saying application, in most of the cases I mean subsystem, because a large application could be composed by many other data-driven areas. So when I say application, it could be just part of the large application, like your core subsystem, right? So what is the domain model? And so in this kind of applications, it is really the heart of your software. You need to think about what is the behavior you wanna achieve rather than thinking about what is my data and what are my screens. We need to think about what is the behavior of the model. And here, I'm gonna, yeah. With this I wanna kind of illustrate what is the domain and what is the model. Okay, so in this case we can have a domain, which is the world. It's one of the domains. It's real, that's the domain. And then we can have different models, different maps about the world. And the important point about the model is that a domain model doesn't have to project everything about the domain. Like that map is representing just one part of the domain, which is the US. Or this other map, and it is an old map from the Spanish conquerors, and that's about another part of the world. Or that's another old map from China, a very old map. And even when this map is old, or this one, it doesn't mean that it is wrong. It was the right model for that context, and it was solving a problem. So it is a right model. And that's an important point. You can have a domain, but then you could have different contexts with different models solving part of the problem, right? So, and this is kind of one of the most important things in DDD. So then if we talk about technical things, a domain model is not just data model, it's not just a relational tables model, and it is not just an object model, it's both at the same time. Okay, so we have to define what are the entities, the rules, the behavior about our domain. And the only way to, or the way that DDD suggests to do this is through code, simple code, C#, Java, or any code, but doing it in a certain way, which is encapsulating or having kind of in the same classes data and behavior, rather than having data on one hand and behavior and methods on the other hand. Okay. Yeah, we need to have like these semantic operations with data, rather than just data access on one hand or data. Right? So this is a very simple example. If we have a class, and then that's an attribute, and then we are changing that data, and that's it from a different method, that is not semantic, because we are changing data of the account from another point, and we could do many other operations from different classes, different methods against that data. But if we have the business rules related to the domain entities, this is kind of a way to make sure that the behavior is being controlled by the entities themselves, okay? Because that method is part of the entity itself. The withdraw is part of the account. Withdraw is part of the behavior of the account. In the upper case, we are doing, at the end of the day, the same operation, but the logic is going to be in a different place than the data. And then, this is very simple, but if you are using the same way, the first line of code, your application will be like a spaghetti code. You will be changing many things from many different points, rather than having a cohesive way of changing that data. So this is kind of the idea. If you have just data as your domain model, just entities with data, with attributes, it's what Martin Fowler calls anemic domain model, or you have just data entities, and then you will be changing that data from like a service or some initial point, and changing this, changing this, changing this, and when this application grows and gets complex, then you will have a lot of trouble, because then if you need to change something, then you will need to search for maybe 100 of places where you need to change that code, because it is impacted because of the change you got. But if you have like a rich domain and domain entities, then everything is more like driven by that behavior of the entities. Okay. This is another pattern related to the entities that helps a lot about driving that behavior. And it is called aggregate. So an aggregate typically is like a group of domain entities or value objects. Domain entity is, like I said, it's data plus methods, both of them. But the important point about an entity is that it has identity. Like a person probably is going to be an entity because you have an identity since you are born, right? And even when you are changing, you have identity. A value object, which is another pattern, could be similar to an entity, but it is not. A value object is just a group of attributes. It doesn't have any identity. And maybe it's just about data. It doesn't have any behavior. So that's why it's pretty different. But then if you group those domain entities plus value objects, that's what we call aggregate. And then the aggregate root would be the entity which is kind of the parent. And then you have several child entities. So, I mean, it's a pretty simple concept. Maybe the most common example is like an order. You have an order, and then you have like several lines, order lines. So maybe in this case, the order is an aggregate, and then the order lines are also entities, but they are part of the aggregate. And in reality, they cannot be an aggregate themselves, because it doesn't make sense to use order lines with no order as the parent. Okay. But I mean, that's a very simple example. But as soon as you have like complex models, it's not clear when this is an aggregate or not, because sometimes you could think that maybe the aggregate should be pretty large with a lot of entities in there, or maybe smaller. So when the model is complex, it's not clear. So the important point is that within an aggregate, which is composed by several entities, it has to be consistent and also persistent as a whole in the database or any data source. And then it is also a transactional boundary. So, and this is the most important point to know about aggregates, because if you think about, okay, so how do I define an aggregate with different entities in there? So you should think about the transactions. So if you think about a transaction that usually is going to work with this group of entities, maybe that's an aggregate, because those entities have to be consistent between them. If you're not going to use several entities within the same transaction, probably those entities should be from different aggregates. Okay. And then repository, maybe you have heard about this pattern, which is more common out of DDD. Is like an abstraction of aggregates, but you could think about a repository as it's not the same, but like a class accessing data and saving data. That's kind of a simplification of a repository, but it's not just like a data access class. It's something more. It is an abstraction of aggregates. Okay, and then you should have like one repository per aggregate. You shouldn't have like one repository per entity. You should group your entities as aggregates, and then per aggregate you have one repository dealing with the database. Okay, so in that way you are kind of driving your design, and everything's going to be more consistent than having a bunch of data access classes and a bunch of entities as data, and then a lot of methods with the logic, and then everything's going to be like spaghetti, right? Yeah, and then of course we will have like methods, operations for loading data from the database or saving data, that everything like dealing with aggregates. Another rule is that the implementation of the repository usually has to be out of the domain layer, because the domain should be kind of what I'd say persistent ignorant. That's one important principle. So if you are using entity framework, or you're using ADO, or you're using Hibernate in Java, or whatever you use, your entities, your classes about your data and that code should be persistent ignorant, which means if you take a look to that code, there's nothing about the infrastructure, there's nothing about entity framework, there's nothing about the technology you are using to access the database. So it's kind of pure code and agnostic, or is not contaminated by the infrastructure technology. Okay? And then, but a repository is using that technology, that entity framework technology, or Hibernate. So that's why you have to have the repositories out of the domain layer. So this is my pure code about in .NET or Java, and then the repositories should be kind of in a different layer, different library probably. But then you might be using interfaces like a contract, and those interfaces or contracts can be in the domain layer. Because I have this domain layer, this business logic, and then I'm saying this is my contract. I need those repositories to work with my domain, but then the implementation is out of the domain layer. Yeah.
What kind of the location you are using to describe repository aggregate? Because it seems to me, if you start to use like Java or C#, use the interface or contract, that kind of stuff, you start to use the Java, then you already tie to the language already, the technology. So it seems to me, if you want to describe repository or aggregate without the implementation specifics, you will need to use something like UML or something to.
Yeah, it has to be your own kind of annotation. Like I'm gonna jump.
Yeah,
well, in fact, next step is a demo to show you that.
There you go.
So
okay, that sounds good.
So I have here, this is Visual Studio and .NET, but it could be Eclipse and Java, and I mean, I remember a conference we did about domain-driven design, and we were a few speakers talking about .NET and domain-driven design, and other speakers were about Java and domain-driven design. And I was hearing like the Java guy talking about DDD, and it was kind of my same language. I mean, it's not a problem, the language, right? So the approach and the architectural approach is the important point. So this is a sample application we created following domain-driven design approaches. I'm gonna just run the app. It's a web application for a minute. It is a, and by the way, if any of you wants this application, just send me an email and I will provide access. Okay. So it's pretty new. Like we were working on this like in the summer and a little bit earlier, and you will see that it's kind of modern as well. So the web is a SPA, it's single page application. It's using Node.js, AngularJS, and all the different new stuff in the website, right? And also, in order to authenticate, we created two ways. You can authenticate like locally using ASP.NET identity, and then it is like the old membership, so it's gonna authenticate against tables, or you can also authenticate against Azure Active Directory. And here, I have the user here. So here it's going to a STS security token service in Azure, and then coming back but in the other case, it would be authenticating against a database table. Now, yeah. So I'm in this user in this case, and this is like an expenses application. It's not a very large application because it's a sample application, but for the sake of the subject, it has like certain business logic related to the expense reports, and then when you are requesting to have refunded your expense report, you can also spend that money or exchange that money to points, and then you can go to a gift catalog and buy from this kind of store. So like different products. So it is like any other domain that we could use, but there are like different business rules depending on the approval processes and so on, right? Like I'm gonna create a new expense report, but you see that it is pretty good, kind of the user interface as well, like Iasa. And then I could add an expense, like let's say flight from Redmond. It's a flight, and it was pretty expensive to come from Redmond to here to Belgium. 3,000. Okay. So here I have the expense detail, and just save it. And get a notification here, and if I come back, I see my new expense report. So this is just a very brief overview of the app, so you know what the domain is about, and then we can take a look to the code. So we have, let's zoom a little bit. We have this web application, right? And then we have several subsystems, which is what we call in DDD bounded context. Okay, so you'll see that we have expense bounding context, catalog bounding context, purchase bounding context, and this is because it is like a small sample application. But if it were like a huge, complex enterprise application, you could have many more bounding contexts or subsystems. And what we'll see is that depending on what kind of bounding context or subsystem we're dealing with, we should have like a different architectural approach. Like in the case of the catalog, this is more like data-driven. We are just updating products and like the Xbox games, and so then it's going to be pretty simple. Just classes, like data access classes, queries, and just almost like a single layer from the web application, and that's it. We don't really need anything else. But then the expense bounding context or subsystem, or the purchase subsystem, in here we have more business logic. We have a lot. Well, it's not a lot because it is a sample application, but if it were real, we would have a lot of ever-changing business rules in here. So that's why those bounding contexts are following more domain-driven design approaches. Like if I go to the catalog, which is the simple bounding context, you see that we have just a few classes, like the product category or product. And in this case, a product, which is an entity, is just data. It's just the ID, title, description, price, category, and that's it. It's not like this is what we call an anemic domain model, because it doesn't have behavior with your entities. Okay, but sometimes there's nothing wrong with that. In this case, it's okay. I mean, this is a simple subsystem, so we are using a data-driven approach for the catalog, right? But if I go to the other bounding context, like the expense bounding context, in here, even when this sample application is small, but we are showing you like a way to create a complex application. And then we have more layers. Like we have the application layer, which is being called from the web application. So the web application, we have JavaScript calling services, web API services in the server, and then those web API services which are in here as well are calling the application layer in there. And the application layer is like the first step, like glue, calling to the domain methods, or then using repositories and saving data. It's kind of, that's why it's called the application layer. Like you see here, how many of you are developers? And because depending on that, I can show more or less code. Or I mean, developers or software architects, or just okay. So
I was before.
I mean, I don't want to get into too much detail, but in here we have the web application, the controllers, which are the methods that we are calling from JavaScript remotely, right? And then here we can see like the expense report controller, and in any of those methods we will be calling the application methods, or like here gate detail expense report, and then we're calling to the application. Okay, but before getting into the application, because it's more like the glue, I want to highlight about the domain, because the most important point in domain-driven design is the domain and the domain model rather than the application itself. So if I go to rather than the application, I go to the domain layer. In here you see that I don't have just a bunch of entities. I have aggregates, and then I'm creating like a folder per aggregate, and let's go to the expense report aggregate. And within that aggregate, which is right now it's nothing less than a folder, I have the different entities. Like let's zoom better here. I have the expense report aggregate root, which is kind of the parent entity, okay? And then I have also other entities or value objects which are related to that group of entities. In this case, the expense, which is like a line of the expense report, or a bonus, or a status, or whatever, right? And this is, if I go to expense report, this is what you were asking about a few minutes ago, right? What was your name?
Okay.
So you said, so how can annotate that this is an aggregate root? So we simply created an interface, which is just something like a name, aggregate root. If I go to the definition, you'll see it's nothing here, but it's the way to name or to highlight that this is an aggregate root. Okay, and because it is a parent entity, it is also an entity, but this is also a way to name that this is an entity. But the important point here is that it's not just an entity with data. Like you see data here, purpose, description, summary, date of creation, a lot of data, but also it has methods, it has behavior. Like, let's look for any of the, like this one, reimburse. And it is part of the entity itself. And then I'm putting logic here that is going to work against my aggregate. Or we should have another one which is like dealing with the expenses or reject an expense report or approve, and it is really part of the entity itself. So that's why we are kind of having a cohesive modeling of our entities, rather than putting that logic in external services or external methods. And then, so that's a rich domain rather than having an anemic domain model.
Can I ask you a question? Right?
Yeah.
So under what condition would you normally make one rich and make another one much more light or anemic?
Yeah, like I said, is if your subsystem or bounding context is simple,
Okay.
is data-driven, like the catalog I was talking about a few minutes ago, then you would use like a plain data model, like just entities with data, with attributes. But then if you have like your core domain, where you have a lot of business logic, domain logic, then for that concrete subsystem, you should use this approach, which is more the behavior of the entities, of the domain entities for that subsystem, okay? So that's why in this application, we have several subsystems. This one, expense PC, is using this kind of rich model with all the entities, with the methods and the behavior all together. But the catalog is pretty simple, because in that case, I don't really, for this catalog, maybe you have another catalog which could be very complex, and then you should follow a different approach. But in our case, it is simple. So in this case, if I go to the catalog, you see that we don't really have almost layers at all. It's just a few entities, and then yeah, that's it, because this is more about the entity framework. So we create the data the first time, so it's just about the entities here. And then another thing is that in the aggregate root, which is the parent entity within an aggregate, it is like a gate in order to access the internal entities. So if I want to do anything about a single expense, I should call to the methods of the aggregate root of the parent entity. Like in this case, add expense. It is a method of the aggregate root of the parent entity. I cannot go directly to the expense or line details, or so it's like a way to maintain the cohesion of the system. Yeah, that's kind of a very high-level overview of the model. I'm not sure if I'm forgetting something important about the model. Well, a lot, but let's see, like aggregates, and then you can say, okay, so how big should be this aggregate, the expense report or the employee or whatever. So you got to think about the transactions. So because when I'm doing a transaction, in this case, to me, it is important that the expenses are treated like a whole unit within my expense report. So that's why I'm creating a single aggregate with all those internal entities. But it's going to depend on your domain. Like maybe the employee aggregate, it has all those other entities, employee factory, picture type. This is what I said. Like in this case, I have just the interface. You see, employee repository. And this is just the contract. This is what I need to have implemented, but out of the domain. And that's why this is just a contract. It's just an interface. It has no implementation. It's just the declaration of the methods, right? Find manager. That's it. And this is what I need for this repository. Okay, so let's continue. Well, this is where you can see the information about the Dino's book. So I want to drill down a little bit on the bounding context concept, which is related to your question. So this is a picture about cells, and could be something comparable. Like human body has a lot of different cells. Like an application could have many different bounding contexts or subsystems. Okay, depending on how large is your application. So the bounding context is like a subsystem, and then a certain domain model applies within a bounding context. So you can have different models within your application, and each model is going to be related to a subsystem or bounding context. Like in that case, I have the bounding context one, or it could be the catalog bounding context, or the purchase bounding context, or the expense bounding context. And then I'm going to have like a different domain model per bounding context.
What if they share common elements?
Yeah, I'm going to get into that. That's a very good question. So you get a book.
Okay.
Yeah, I mean that's one of the most important questions when people start thinking about domain-driven design, because we are used to think about reusing everything, right? So I have a database and I have logic, and I want to reuse that everywhere. But that works great when the application is small. But when the application is super large, like maybe an ERP or whatever, then is when you have like methods with a lot of data that you are getting but you don't really need, and then you're having a lot of complexity because you are trying to reuse everything for all the different subsystems. And that's the difference between like kind of trying to reuse everything, and that approach doesn't work for complex systems. And so this is the case. Like in this case, we have the domain, and then this is the model for that bounding context. We are dealing with a lot of behavior and logic about the US. And in that case, we have a different bounding context related to the world as well as domain. But then, in this case, this bounding context would be like an old application or map that was used many years ago, but different people with a different purpose. And it is also right, okay? So, yeah, this is what I said. Like in a typical large enterprise system, we will have like multiple bounding contexts, and it's not just about 2 or 3. It could be many more. Then there's a discussion between should it be a lot of very small bounding contexts or less bounding contexts but larger. It's going to depend on. It's not a problem of if it should be larger or smaller. It's more about boundaries. If you see one area which is not related to the other, then it's a good candidate to separate that. Okay. And
Well, what's your criteria for deciding? Because you can have, like one view of the world that we use a lot is you have sort of a system of interest, then you have like regulatory things that they have to worry about, and then technology they have to draw from. And you'd like your domains to be such that you could manage certain piece of information, well, down here and up there with common, you know, I maybe call it helper domain. Need a helper domain maybe to.
so most of all is something that is like a subset that has to be consistent, and then maybe for sure it's going to have relations with other subsystems. But if you see that it is kind of just a little bit more isolated, like in our case, the catalog is more isolated, and then sometimes from the expense subsystem we are talking to the other subsystem, or so. But it's more a matter of thinking about all the entities and kind of making piles of entities and even attributes. And then when you see that something is kind of more isolated, that's going to be a bounding context. And also, usually it's something like an area where could be, you just think like, hey, this area could be created by this development team, by this group of developers. That's probably a good bounding context. If you think, hey, this area is so related to this other area, and I kind of have two different group of developers working on each, probably should be a single bounding context. But it also depends. This is more like this is not science. It's more like depending on like Eric Evans. If you read his book, you'll see that he thinks more about kind of a little bit larger bounding context. But if you read information about bounding context from Udi Dahan, maybe you have heard of him, and what's the name of the service bus? And service bus, and he also talks about a lot about this. But he thinks about a smaller concept of bounding context. So this is not like
so what do you do in the situation where you decide you're going to clone a bounding context? So you have one, you decide you're going to clone it.
Clone it.
Because you want this to either have more attributes or do something slightly different, but there's still some commonality between them. Then how do you synchronize?
Yeah, I'm gonna get to that point. Yeah, because sometimes, for sure, you're gonna have like a part of the same entity in both bounding contexts. Like customer. Hey, I have a customer, and I have to deal with customers from this subsystem and also from this subsystem. And I will get to that point in a few minutes. Okay. But the important point is that within a bounding context, it gives like to the team members, the developers, a clear and shared understanding of what has to be consistent as a whole, as a subsystem, right? And you can also even develop or create that subsystem independently. Like, I don't care if that other subsystem is not working, my subsystem is going to be working. And then we are integrating the different bounding contexts asynchronously. And that's the point. If it is asynchronous, then it's gonna work. If it is synchronous and you depend on the other subsystem, then that's an issue. Yeah.
How do you take the performance into consideration when you try to use the DDD? Because you need to be careful about balance. You don't over define your domain. So
that's not an issue in DDD. I mean, even I'm not sure if you're talking about maybe that we are creating more layers or something like that.
Right.
Yeah, but that's not an issue. I mean, if you measure like a call within the CLR or Java virtual machine, just calling one method or calling 3 methods, that's not the bottleneck. The bottleneck is going to always be like accessing your database or the latency between the network or things like that. So that's not an issue. So and then even more.
So you're seeing the abstraction will cause the performance, because usually if you add the abstraction, more and more abstraction to your code, your design, you're going to add some burden. I mean, usually, I'm not saying it will be 100%, but usually, earlier you mentioned about, you did point out you do have abstraction there. And I'm just worried about
you don't really have abstraction layers. It's more like subsets of code. You are placing different code, different type of code in different subsets. It's not like a lot of abstraction layer. So I don't think it can impact the performance. On the contrary, if you have a system with a lot of transactions, and then you are applying in the right way the aggregates definition, then you're going to have a much better performance, because the aggregates boundaries are going to work in a way where you will have a lot less of blocking in your database because of the transaction boundaries that you are creating. If you don't have that, you're going to have, the database is going to suffer a lot more
you try to decrease the access time to the
Yeah.
database. Okay.
So if I can just add to what he is asking, I think I architected one solution for healthcare on domain-driven design. Right now it is in New York. Related to your question, like performance thing, I think you are referring more because there are so many layers and classes being cut
Right.
through. And so Marty Fowler is a great follower of solid principles. He talks about that. And when we architected the solution, we were doing that for healthcare. And we also implemented lazy load pattern. So whenever you are invoking an entity, it doesn't load just like that. So it's lazy load. So basically it's loading, but it's not pulling data unless it is really required. So performance is something which you can still take care of because domain-driven design is, as far as I understood, is a principle. And then it is revolving around so many design patterns, like repository, aggregate, visitor, there are n number of patterns.
So you're not seeing the, when you do the abstraction and do the, I'm not talking about data loading, more like the implementation realization, right? You interface or abstract.
You are talking about generalization and specialization.
Right. Would that kind of cause you some performance hit?
I think maybe we can take it offline. There
Yeah.
is some matter of discussion. I would like to
I mean,
understand how it
of course it is,
Yeah.
it depends, of course. I mean, if you're looking just for performance, pure performance, like graphical or whatever, then you might be right. But in a typical enterprise business oriented application where the bottleneck is not the execution of the methods, it's more about the database or the remote services. I mean, it's kind of nothing. It's like.
And in addition to that, domain-driven design is always at the binary level. So you are designing the API. It's not at the layer of your database or front end.
Yeah.
It's mainly the API, the framework you are creating.
Yeah,
That is so lightweight. That is so lightweight. The binaries, DLLs are so lightweight that it doesn't hit any performance when it comes to deployment.
So, yeah.
How do you apply these principles to the cards applications? For example, some of the packages comes of the market, the SAP or the auto management systems, which are typically follows this principle. Those are driven by the API framework. But at a high level, how could these principles be applied to those when you're designing or implementing those?
I mean, in the same way that in a custom application, the difference might be in an ERP is that it's not just for a single case. Usually they want to have like a more abstraction, because then they want to have like a business guy creating a new entity, and then it's going to have like different levels. And then in that case, it's going to be different because it's more like metadata. And usually, DDD is more like modeling your data with its own behavior. It's not like metadata. So you could apply certain DDD patterns in ERP internally, but maybe other patterns are not really the right approach because you are kind of integrating data with behavior in the code, and then if you want to have like metadata, then it won't work. But many other patterns could be, or maybe the bounding context concept could work as well. Like you have an ERP with the payroll subsystem or different subsystems. So, and like I said, domain-driven design is not like science and you follow from A to Y and that's it. It's more like approaches and a way of drive your project and architectural approaches. And probably if you go to a different project, it won't be the same. It could be pretty similar, but depending on the domain, it's going to be different. So this is regarding when you're defining the domain model and regarding your question. In here, we can have, this could be like a conference system. We have a lot of different entities, and these are just a few. If you have a large subsystem, you might have like hundreds of entities, right? And then, if you think about, in this case, just entity framework, where you have like a unit of work or DB context, and then you could have like here a bunch of tens or hundreds of entities. If you have a single domain model or a single model for all your applications. So in many cases, you might have performance issues, but most of all, this is going to be a nightmare regarding applications maintenance. And this is more, DDD is more about complexity and simplifying the complexity more than any other thing, right? So maintenance in the future is key. So what we want to have is trying to identify different bounding contexts, different subsystems for the conference application in this case. Like we might have like a conference management subsystem where we have users, attendees, registrants, conferences, organizers, or we could have a payment subsystem where we have registrants and payments and external gateway, or customer service, or orders and registration. So you see that many of the entities are just within one of the bounding contexts, but maybe other concepts are in several bounding contexts. Like registrant, we have a registrant here in the payment subsystem or payment bounding context, but also we have a registrant in the conferences management subsystem. Okay? But the important point is that in this case, it is the same name, but it might be a different name. And also, it might have different attributes, and that's the key. Okay? Maybe the ID, and that's why I said the most important point for a domain entity is the identity. So the identity of this registrant is going to be the same than this one, but probably it's just about the identity. Maybe the attributes are different in the different subsystems. And even the name. Maybe this is a very complex subsystem with a domain, and maybe the ubiquitous language could be different. Like maybe in here is a registrant, but maybe here I call it buyer. Okay.
But okay, let's say you have a registrant in 2 or maybe all 5 places, and you're right. You may not care about all the attributes. You may care about different sets of attributes in different, I guess, clouds or domains. But are you building the argument that there should be one registrant class, or should there be 5?
Probably 5.
That's where I tend to disagree, because I think there should be one registrant class that has maybe more attributes than you need in some of the domains, but at least the ones that are common can
So that's the traditional approach. You have a large domain entity or entity with everything you might need, and then maybe it has like tens of attributes, and then you might get that entity in a subsystem, and you're not using all of them. And this is the difference in domain-driven design. Like if I'm talking about the registrant, this could be like what you're saying could be, it could have like 30 attributes, and what we're doing, we are segregating or decomposing that registrant into different classes. One would be for the conference management bounding context, and in here I just need the first name, last name, address, and company. But in here I don't really care about maybe the status, if it is like a premier guy or whatever. So in here I just care about the status for this class within this price and BC. And of course I will have the ID, and the ID would be the same here and here. But I'm kind of segregating the
Yeah, but let's say I change the ID, so maybe it's a customer number. So I start out with
That would be
six-digit customer number.
yeah, that would
But
be
then I get crazy, so now I need a 10-digit customer number.
that would be an event. Something happened in this bounding context. This registrant has changed, and then I publish that event into my. That's kind of the integration between the different bounding contexts. I publish that event into an event bus, which is could be a bus, or could be just in memory, could be whatever. It's something asynchronously. And then the rest of the bounding contexts are, I'm using the publishing subscription method. So I'm publishing that event, and any other bounding context that cares about that entity, because it was registered, I will get that information with that event, and I will apply that information that I care into the other.
So in this case, you would have a method for, you would send a message to the other 5 things saying, okay, I need to expand my field.
Yeah. Not a direct message. It will be a single publish to my event bus, and then all the different subsystems that are subscribed to that bus will get that message and will act in consequence.
How did you implement that? Is it implement part of the code, or you already have a kind
So
of requirement for
it will be part of your code. I can show you. I mean, if you get this example, you will see it,
Yeah.
and we are using that.
Yeah.
We are publishing an event in an event bus. In this case, we are using like a in-memory bus. In fact, we are using dependency injection so everything is kind of in the same process. But if it were like a large subsystem, you might be using a Azure Service Bus or and Service Bus from UDI or many other different. I mean, if everything is a single process within the same web application, like in this case, and it is a simple sample application, you don't need a service bus.
Interesting.
But if each bounding context is running remotely, because maybe I'm having a few servers for this bounding context, other servers for the other bounding context, then I will need something, a service bus remotely and so on.
I just ask, what's your primary rationale for using a service bus across domains? Is it just typical, or is it just you're asking for a deep level of decoupling between the two?
I'm not sure if I get the question.
Well, you could call between them and then map data as it translates from one to the next, but you're choosing specifically to use an asynchronous bus.
Yeah.
I'm just asking like primary rationale for choosing that as a way to connect.
So the important point is that it has to be asynchronous. And then it could be a real service bus, or it could be in-memory bus, or whatever. If it is in memory, maybe it's my own implementation.
So this isn't for like a query scenario?
No, everything, and that's a really important point. DDD is more about the transactions, the tasks, the updates.
Okay.
When you move to the queries, I would even, and that's what we did in this example, if you're just querying, I would forget everything about DDD and just do the queries even from the website, what you need in the database or whatever. Because all the complexity we are talking about here is because of the transactions. I'm defining also like aggregates because of the transactions. But if I query, I mean, a query is like, I don't care if I query once or 1,000 times. I'm not changing that data. So for the queries, I don't care about aggregates, I don't care about anything. I just want to go to the data and grab that information. And then when you are updating, and we use what we call, and it's pretty typical in CQRS as well, we use the concept of command. A command, it's like a group of data that you need to execute a task that is going to be in reality a transaction. Okay.
Just out of curiosity, how long does something stay on the bus?
The message?
Because you said it, well, you said it's asynchronous, so you're putting information on the bus that I changed.
So usually would be like milliseconds or things like that.
Well, I mean, does it have a death? I mean, does it, or you just store stuff on the bus forever, is the question.
Not forever, it's going to be processed. So it depends if you are using queues, on message queue system, and then you will process that message.
But the reason I'm asking is because if it leaves, let's say one of your clouds is temporarily down for some reason, doesn't get the change.
Don't you have to build for rather pessimistic scenario?
So that's another good question. And if you are creating different bounding contexts, you have to accept the concept of eventual consistency. Like when you do this operation, if it has to be like right at that moment, transactional, atomic transaction with this other area, then maybe you can have a different bounding context. So if you have different bounding context, you have to accept that you can have eventual consistency. And eventual consistency means that you will get consistent with the other bounding context eventually, like in a few milliseconds or a few seconds or later. It's like when you create these kind of systems, it is also dealing with high scalability as well. Like if you think about Amazon, sometimes you do something and then it says, okay, it's done. But then you go query and you still don't see it. That's because they are using, because of scalability reasons, they are using eventual consistency. And then after a few seconds, or maybe sometimes could be even minutes, or it depends, it will get consistent.
But that's why I asked the question, how long? This presupposes,
So
I mean, it's asynchronous.
How long?
So it presupposes that it's going to be on the bus until all the subscribers have had access to it. But I'm not
So
quite
that-
sure how you do that.
It depends,
Yeah.
and if it's
So-
in memory, it's fast.
The important point here is you gotta go and talk to the domain expert and say, okay, is this acceptable for you as domain expert? Can you wait a few milliseconds, a few seconds, or even minutes, or even days, or you cannot? And then depending on the domain expert, you will go for this approach or not. But if you think about many cases, it is acceptable. Even like the example that Greg Yan says, even in banking, sometimes you go to an ATM and you do something, and then maybe it's offline, and your account doesn't have it right away. And then when it is online, it will generate the event, and then you will be eventually consistent. So
Right, but that's a great example of the argument that it's got to stay there until everybody that possibly needed it
yeah.
has had access to it. You can't afford to time that one out.
So it depends on the domain.
Do you ever
Tour
use
bus.
this kind of concept for two different applications, two different bounded contexts to talk to each other?
Can you repeat?
So right now we are only talking about this within one application. So it pretty much that you have different bounded contexts talk to each other through the service bus. Right?
Yeah.
Have you ever used this kind of concept kind of scale to different applications?
Yeah, and I was gonna say that.
Comprise-
Precisely, because as soon as you have different subsystems integrated in this way, like in a publish subscription way, that's a perfect way to integrate with a different application. Because then it's like a gate you are saying to another application, okay, you just subscribe to this event and we are integrated. So in this case, you see that each bounding context could have its own domain model or even its own database. Could be a different server, database server as well. And then this asynchronous communication between the different PCs are based on events. Something happened in the past in this bounding context, and then I'm communicating this. You see different arrows in here. In reality, would be a single point or infrastructure when I'm publishing the event. And then any subsystem or even external application, in that case it would be an integration event, it's going to be reused. And this is something also,
Cesar,
yeah.
can I just add something
Yeah.
real quick? So I am right now working as an architect with Frontier Communication. It's a telecom company. And just to answer your specific question, they are using multiple diverse systems in different silos. So their website, which they use internally, is having two different systems. One is for billing, that's a DPI, a company who designed the whole system for different telecom companies. And another one is Triad, which is for provisioning. So when you log in as a subscriber, we are using an enterprise service bus, which is talking across all these systems. When their Frontier Communication customer care people are logging in, they will put you for billing in one system and then for provisioning into different system. So those are two different systems altogether, living in two different domain models and then communicating via enterprise service bus. So request travels through that.
So the question will be, how did you manage that type of standard communication between two different silos?
Yeah, that's the domain again. Network, telecom is a domain. So as Cesar mentioned, I think
Yeah.
in very earlier slide, it's a ubiquitous language.
Yeah.
So
And then there are kind of approaches for integrating different subsystems or different applications. So like Eric Evans calls that what's the name? Anti-corruption layer. Like maybe this bounding context is maybe a black box, old, and then I want to integrate that with this new domain-driven design, cool, and then I might need something in between to translate from the old model to the new model. So that's the anti-corruption layer or shared kernel. There are different approaches for that, but it's theory that you have to apply in your code. And this is other important, I mean, I also mentioned that, but I want to highlight it. Like if you have like a large composite application with different subsystems, different bounding contexts, usually you should have different architectural approaches per each. Like in this case, I'm talking about a layer, domain-driven design. That would be for my core domain, maybe. But maybe I have an area, which is the catalog or whatever, and I just need to read and save data into tables. So I don't need DDD, I just have like user interface, data access layer, talking to the database, and that's it. But then we are integrating those subsystems in the way we said, like through events. So events is super important in DDD, these kind of subsystems. I mean, we could talk a lot about events, but we won't have the time here. So, well, I showed you the kind of the different projects for each bounding context, so we don't need to go here. I also wanted to highlight this. I'm not sure if you know it. It is called the Snowman architecture by Roger Sessions. It is not really DDD, but the concept is very, very similar to the bounding context. And in DDD, you have to think about, I mean, like taking a look to all the relationships and so on. And in this is very similar to a bounding context, and he calls that Snowman. Like Snowman would be a subsystem or bounding context, and then you have business architecture, technical architecture, and even data. So it's pretty similar, and then this is kind of the asynchronous communication with other bounding contexts. What Roger Sessions did, and do you know that? This approach? He created kind of a mathematical approach in order to kind of identify what number of bounding contexts you should have for this kind of large subsystem and so on. It is pretty interesting, and it kind of engage or connects with DDD. Like then you can have a lot of different subsystems in a large application, and the reasons why he's saying that is the same reason that we say this in DDD. If you have like a lot of complex domain dealing with many other logic, many different databases, and it's going to be in the long term very hard to change. If you are partitioning that complexity in different isolated subsystems, and then you are connecting those subsystems asynchronously, in the long term it's going to be much easier to change, because you might be changing something here and you don't need to change anything here because everything is kind of well driven. If you change something here, you might need to change things here. That's the approach. And then we have different patterns in DDD. We talked about repositories, aggregates, entities, value objects just a little bit. Factories is another way, and services, but we don't have the time for that. Layers versus tiers. Like this is just something simple, but tiers are more like the deployment level, where you are deploying your application, your processes, and then layers are more logical. Like in the case in this example, we have a single tier, which is the web application, but internally we have many different layers. But because everything is like binary, the performance is not really impacted. Because I mean, in that web application, in our example, everything is running within the same process. So the bottleneck is more when we are talking to the database or external services, or if we have different tiers, the bottleneck is going to be when we are using services, remote services. And these are kind of the suggested layers for in DDD. Then I just want to highlight that it is also important to have decoupled architecture, so using dependency injection. We cannot get into details here, but this is important for the long-term applications and also in order to have a good unit testing, and you can have better fake smoking. But if you go to any kind of serious development in DDD, or even without using DDD, I really recommend using dependency injection.
How good is this if you try to apply the aspect, ASP in the aspect-oriented programming?
Aspect-oriented programming?
Yeah, so I'm not sure what kind of relationship.
That's different. It's more, yeah, AOP is more like you are putting annotations in your classes, and then kind of magically you're putting behavior in because of those aspects.
Yeah,
so it's kind of sometimes it looks great, sometimes it's kind of dangerous. Because
yeah, I'm just curious whether can I use the DDD concept to apply to the AOP. I'm not sure. I'm just kind of curious.
It's kind of different level. Of course, you could apply AOP in a DDD project in the same way that I can apply dependency injection or not in a DDD project. You could also even implement AOP aspects using dependency injection, which is using interception. But there's also another way for AOP, which is aspect weavers. So when you are compiling the code, those kind of annotations are generating code in the compilation, and then that's the execution. But AOP is, I like it, but sometimes it's dangerous because the developer that didn't create those aspects is kind of magic. So it's happening, but I don't know why. You know. And also, dependency injection is great for isolating the different layers. And in this case, in DDD, I want to isolate the domain model layer from the infrastructure. So if everything is decoupled through dependency injection, my domain code is going to be kind of clean. I won't have anything related to entity framework or Hibernate or whatever technology you're using underneath. Right?
I have a question. Would you have a problem? I haven't read the book yet, but would you have a problem with two different domains modifying the same set of data, or would you expect one domain to own that? For example, address line 1. Would you allow two different domains to have to make the same change, or would you?
Not the same attribute.
Okay, that's what I.
So it could be what we are saying here.
Okay.
Here. So if you mean kind of the same concept, like registrant, then yes. But the status attribute is here, just here. It's not in the other
So
one.
it's owned by that domain, technically.
Yeah.
So his example where you address 1, so you change it, then you're gonna have to go change it everywhere.
Yeah, well, you
So how would you do that? Would you post an event to the bus and then have a poll for address changes?
So all the subscribers that are interested in the
so
app
that's
can subscribe to it.
So ideally, you has to have this attribute just here, but sometimes, I mean, it's what you are looking for.
Right.
But sometimes, if you need the other data, then you could have it, but it's more like a snapshot. Like this would be kind of the gate for the first name, but hey, I need the first name here as well. I won't change it, I just need it when it is changed from here. So you can have it like a snapshot. But that has to be clear in the code, and like just the aggregate logic in this bounding context should be the one changing this attribute. It's like an order of priority.
Yeah, that's clear.
But, well, I didn't really understand your answer though, for like the address or phone number or email changes, that you want to propagate that change all over the place. So,
Yeah, that's what I said.
So if I can add back to the real example in Frontier, how they do it. If you call, the customer care person would be able to tell you without taking even a single second that the set-top box, the device where you have, is at a different location than your billing address. Because billing is coming from a different system and provisioning is happening from a different system. And how we show it, we show a little small triangle with a yellow exclamation sign in it. So if you want, you can call them, hey, you know what, my provisioning address, my home address is my billing address. And that provisioning is happening at a different place. So how we do it, we are using SOA architecture around it, WCF layer, and we call update subscriber method because it's a domain-driven model, and telecom people call you a subscriber. So we are also using that subscriber term there in the entity model. So we invoke update subscriber, we pass the new address, and that travels through the enterprise service bus and notifies the DPI system, the billing. And that triggers an event that both the addresses are same now, and then we show that right green color check mark instead of a yellow exclamation in that. So this is how both the address entities of two different systems are communicating. I hope that answers the
Because
question.
sometimes it is the same data, but maybe it's a different name.
Right.
Because the ubiquitous language for that subsystem is different. In a purchase subsystem, maybe it's a different name for the entity or even for the attribute. But then you have like a mapping
Exactly.
with
We
the
have a
other,
map, yes.
a mapping with the other subsystem where the entity is kind of the same identity but different name, and even the attribute might be different because the language of the domain experts of the other subsystem is different. So at the end of the day, it's like integrating different applications. Yeah.
And there are various mapping tools available to map different entities.
Yeah.
So if you change one entity that maps to another one, it automatically gets reflected.
And then I don't have the time to explain. So because what time is it?
7:30.
7:30, yeah. But I want to highlight this other approach, which is CQRS, Common and Query Responsibility Segregation. It is very related to domain-driven design patterns, especially in the transactional area. So what means this approach is we are separating the queries from the writes or the transactions or the updates, okay? Because in a regular or typical layer architecture, we have a domain, we have reads, and we have writes, and then the domain is the same. The repository is doing everything, reads and writes. But then, if you compare reads with writes, it's very different. You can have many more reads than writes. Queries are fast, synchronous, idempotent, so no matter how many times you do something, data won't change. And also you could have stale data, like sometimes you are querying something, but because of optimistic concurrency, maybe it doesn't matter. So you have to accept that in most of the systems, you have stale data. But then writes are slower, asynchronous, stateful, and in this case, you cannot have stale data. So what CQRS suggests is, and of course it's transactional, is to segregate those operations. Like, first of all, CQRS is not a top level architecture. Maybe it should be just for one bounding context in your system rather than for your whole application. That's important. And just for certain scenarios. Like again, this picture, in that case, maybe for this bounding context, we have the CQRS approach, but not for my whole application. So what means is that one important benefit in CQRS is that the queries is really simple. We just query the database and get the data, and there's no complexity in there. It cannot be simpler than that. It's just a single layer. But then for the transactional area, we have certain patterns like commands that I said, domain logic, and data persistence, and this would be following domain-driven design, aggregates, patterns in DDD. So this is kind of the approach we have in the example that I can provide you if you want to take a look. We are using DDD patterns just for the transactional area. When we are kind of creating an expense report, or we are submitting for approval, and all those actions are commands, and then we are applying all the DDD patterns, aggregates, and domain entities, and so on. But then, regarding our queries, we are just querying from the web's JavaScript to services, and those services have like a single layer of methods, query methods, and just querying the data from the same database. And in this case, queries are super simplified. We don't have any constraint querying whatever we want in the database when querying. But then we have a lot of constraints in the design from a DDD point of view because of the aggregates and so on. But then CQRS could go even further. And given that we are separating or segregating the queries from the transactional area, you could segregate the data stores. You could have one source of truth of your data, which is where you are executing the transactions, where you are persisting the data. And then you could have another database which is just for the queries. And this could be because you want to have like a much higher performance in scalability. So this database could be denormalized. And usually in this approach, each table is in the form like if it were a DTO, data transfer object, that maps exactly with the screen you need. So you don't need to do any query between, any join between different tables here, because you are creating a single table per screen. So it's going to go super fast. But then in here you're going to have work in order to kind of translate from the source of truth that you have here to the denormalized database. So here is where you have more work. But in this case, for the queries, I mean, you can have the junior developer just doing a query with no joins. I mean, it's going to be super simple in that area.
You have replication.
But again, in this case, you need to have eventual consistency between the queries and the transactions. So your domain has to accept that. If you can have eventual consistency between the queries and the transactions, you cannot use it. But this is the approach that many large, high scalable systems in the internet are using, like I said, Amazon or whatever. They are using this approach because of the, and also it fits great what Uri-Dahan calls collaboration systems, which means that you have users competing with, for the same resources, like a reservation system for in flights or things like that. And then, of course, then you could scale a lot here for the queries. And this is kind of architecture. So you have, this is very simple for the RITs, just a data access layer. In here, you don't need anything about DDD. You don't need aggregates, you don't need, it's just querying, and that's it. But then, here you have commands. A command is something that you want to do, like a transaction. Command handlers, you get that data, you persist, and then you send an event. And this is this way of working that I have like an event handler of what happened here, and then I want to kind of translate that information into the other register. This is exactly the same approach that we have to follow if we want to integrate different bounding contexts or different applications. So we are publishing an event in the event bus, and then the other area of the CQRS is processing that. Maybe it's denormalizing that data and maybe this could be SQL, but maybe this is like a NoSQL database or whatever. And here you have a few resources about CQRS. So that book of patterns and practices about CQRS journey, I was also working on that for a while. And then Udita Han and Greg Young are the most important promoters in CQRS. Greg Young also talks a lot about event sourcing, which is another topic related, but it's event sourcing means that rather than having the current state database here, like a regular SQL database, you have a bank account and you have how much money you have, and then if you take money, then you have like minus 100, and then you have, rather than 100, you have 90 or whatever. That's current state database. Event sourcing is, rather than having current state, you are storing events. The same events that we are generating here.